This is Precalculus, Chapter 12 review. You can look on the board, guys. I've written the problems from the lesson that are important and the problems from the review and some topics. So, we're going to start on page 787 with example 9. So with example 9, you're combining two things. It's almost like the chemical mixture problems in Algebra 2, right? You have one equation that is how much of each one, and then you have a weighted equation. So in this case, we're mixing two coffees, right? In Algebra 2, we mixed a couple of chemicals to yield a couple of different concentrations of chemicals of a substance to result in another substance. You remember that? Like if we're going to combine alcohol 10 plus alcohol 50 to yield an alcohol 40, how much of each do we have to have? And then we multiply that times how much alcohol 10 we had. You know, we multiplied the concentrate times how much of each one of these concentrates we had, right? Example 9 is the closest to this, where they have coffee. They have Costa Rican, plus they have Kenyan. We were making 1 pound of coffee. Then they have the price. One was $4.50, one was $7, one was $4.50, one was $7, and they wanted to pay $5, right? This was going to be the mixture, but we wanted 1 pound. So that would be times 1. Notice I just put 1 decimal place because there are zeros beyond that. Then you can eliminate the decimal places. Okay, so being able to read the problem and logically set up equations will be important. I do want to work from this lesson, number 40 and number 43, which I have also placed on the board. Let me go back. I don't know why I'm going back. I should just read out of my book, huh? All right. Setting up the equations is the hardest part, right? So look at number 40. The sum of two numbers is 40. What do I write? Sum of two numbers, x plus y. X plus y is 40. Actually, this was just on my Algebra 1 test that my Algebra 1 students took. The difference of, so what am I doing?
Subtraction.
The difference of twice the first number
2x
and the second,
minus y.
yep, is 11. What are the numbers?
Could you do substitution?
What would you do?
Oh, elimination.
I'd do elimination. And you got it, right? All right, let's look at 43. So we're really just setting up the equations. An investor has part of her money in an account that pays 2% interest annually. Okay, I don't know what we want to call this. And the rest, okay, we'll do part 2% or 40. Got it? So part is 2%, rest is 4%. You know, you just have to decide what you're going to use. If she has $4,000 less in the higher paying account. So what is that? Actually, let's call this high and low, since that's now what they're referring to. If she has $4,000 less in the higher account than the lower. So what is that equation? Okay, 4,000 less. What do I write there?
Negative.
Minus 4,000, right? 4,000 less in what account?
Higher rate.
Higher. Where does that go? Huh? Is it H minus 4,000 is L? This says the lower account has 4,000 less than the higher. But the higher account, right? Higher account has 4,000 less than the lower. All right, so once you write it, think, is that really what it's saying? And her total annual interest income is $1,010. Interest, $1,010. How do we calculate interest? Yeah, you got it?
It would be L plus H.
Okay, it's going to be the amount of interest I earn on my high account plus the amount of interest I earn on my low account. But interest is calculated by taking how much I have in my high account times 0.04 plus how much I have in my low account times 0.02 equals this. When I have decimal places, make sure you write decimal places everywhere, because then you can just eliminate the decimals and then solve. You could use substitution, right? So for high, I would substitute in low minus 4,000. That to me seems like the easiest way to solve this.
Whenever you move that decimal place over from the
Right?
would you just add 2 more zeros? No, not add, like.
Yes, it would be 101000 equals 4H plus 2L. And then for H, I would substitute in L minus 4,000. That to me seems like the easiest. All right, now let's go to the review and let's look at 1 through 11. Maybe we'll work 16 too in the review. Let me get to the review. I do think we might need to work 16. And went too far, of course. Okay. So how are you going to work number 1 in the review? How should we?
Elimination.
Just
Multiply
multiply the second equation by 3.
the second equation by 3. All right, and then you can use elimination. All right, let's just walk through these. Number 3, how are you going to solve number 3? Anybody?
Multiply the first equation by 4 and the second one by 3.
Okay, first one by 4, second one by 3. Make one of them negative, right? Change all the signs. What about number 5? The instructions are solve them by any method.
So could you make it into
What?
you can put it into the matrix.
You can put it into a matrix. All right. It said by any method.
Okay.
You have methods, right?
5, 7 I could not get by the way I had been trying to do.
Or you'd have to use elimination twice, right? Okay. So, how would I put it in my calculator? How are you doing? What's your matrix of what by what?
3 by 4.
Okay, we can do 3 by 4. Remember, you have options. What are the two options of solving these? If we put in a 3 by 4, how are we solving it? RF, that is correct. If we put in a 3 by 3 and a 3 by 1, what are we doing? Remember, we can put in a 3 by 4. That's the augmented matrix. If we do a 3 by 4, that's the augmented matrix. Right? Let's tie this in to what's going to be on the test. Or we could do and this is when we're going to do RF. If we did a 3 by 3, so that was just the coefficients, and then if we did a 3 by 1, then what are we doing? We're taking the inverse of this one and multiplying it by this one. Right? We would take the inverse of the 3 by 3 and multiply it by the 3 by 1. All right, so what do you get? X equals?
X equals 35.
Y equals?
Negative 17.
And Z equals
22.
22. All right, let's jump to number 9. Let's do the augmented matrix here for number 9. So it too is a 3 by 4. And let's see what this one looks like, because this one is going to be, oh great, I have it as a 1 by 2. Hello. Quit. Matrix, edit. It's a 3 by 4. Remember, you need, in that second one, you need a placeholder for X, right? 10. Number 9.
Is that 0 for X?
Yes, put in 0 for X. Make sure I put this in right. 0, 8, 1, 2, 3, 0, 5, 10, 8, 6, 4. And then go do reduced row, echelon, RF. That's under math. All right, so for number 9, is everybody here yet? You got it? What does your matrix look like after you do reduce row echelon?
For what number?
Number 9.
Oh.
Do you have 1, 0, 1, 1, 0, 1, 2, 0, 0, 0, 0, 0? What does that mean? Infinitely many. All zeros, means infinitely many.
So what would you put for the answer?
Infinitely many. That's what I would put. I mean, there is, you know.
Why? Oh,
You didn't get this?
no, I but
When would it be inconsistent? If you had something like this is inconsistent. All zeros and a number. 0 doesn't equal a number, right? This would be no solutions. That inconsistent. Let me see if there's one. Okay, let's do number 10. Let's do number 10.
I'm confused from what you did for 9.
Yeah, I keep getting like it has solutions.
Yeah.
I don't know what I'm putting.
Your matrix, do you have 0 for x for the second one? Did you put 0, 5, 10, 0 in your second row?
I'm pretty sure.
I'm gonna come look. Let me look at your matrix. You know, sometimes a different eyeball. Are starting all the way over, right? 3 by 4. Okay, 1, 2, 1, 0. Oh no, 0 is x.
Oh.
5 is y. Okay. All right. So normally just starting all over, right?
Okay, I did it a second time and it went
Okay. So when we work number 10, do you get 1, 0, negative 1/2, 0, 0, 1, 0, 0, 0, 0, 0, 1? Okay, that's where the 0 equals a number. That is inconsistent, no solutions in common.
So for 9 there was a solution.
Infinitely many solutions for number 9 because of the way the matrix looks. All zeros at the bottom means consistent, infinitely many. When you have those 1 diagonals, right? Zeros above it, zeros below it, then a row of numbers, that means consistent 1 solution. So we've worked 1 of all 3 types, right? All right, so that's no solution. All right, let's work number 11. We'll just write the equations. The sum of one number and 3 times a second number. What do I write?
X plus 3y.
Yeah, x plus 3y is negative 20. The sum of the second number and 2 times the first.
3y plus 2y.
I think it's the sum of the second, not 3 times the second, right? And 2 times the first is 55. And then you could solve that, right?
Mm-hmm.
All right, let's do 15 and 16. Y'all can solve these, right? You could actually put those in your calculator too, but you would have the x first, right? For that, you could put those as a matrix, reduced row echelon. Or you could do algebra, right? You can work those both ways. All right, let's do 15. I'll give y'all some time to go back and, let's do 15 and 16. Tickets to a lecture cost $1 for students. Almost didn't write a one. Okay, $1 for students. $1.50 for faculty, and $2 for other. I'm going to put a line through it to know. Total audience at the lecture was 460. What do I write there? Total attendance at the lecture was 460. S plus F plus O is 460. The total income from the tickets was $570.
Would you do the same as plus F plus
Or wouldn't you
1
do-
S plus 1?
This is number of people. I want number of income. How much income? Remember, this is how many. This tells me how many, how much. Go ahead, Rose.
Would it be 1S plus 1.5 F
Yes.
2 O?
And I'm going to write everything with 2 decimal places.
Couldn't you just write it with one decimal place? Or do you?
I could write it with just 1. Yes, yes. Let's do 1. That does make it easier, huh? Well, it doesn't really matter. I'd probably put this in my calculator. Equals 570.0. And then you could just eliminate. That'd be 10S plus 15F plus 20O equals 5700. 3 times as many students as faculty attended. What do I write there? Who do we have more of? Students or faculty?
Students.
Students. So then I'm multiplying 3 times F. How many faculty members attended? Okay, you have 1 equation. You have 2 equations. That would be plural. That's right. So then we have this one. I could put all 4 of these in it. I could put 1S minus 3F plus 0 others equals 0. I just said equal to 0, right? Then I have 3 equations that I could use the matrix with, right? I just put this equation, all 3 variables. All right, let's do that real quick. Let's see if we come out with a... We just want faculty, so we just want that middle number.
Wait, so which are we putting in?
1, 2, and 3. I labeled them.
So where are we putting them into?
The matrix. 3 by 4. That's what I'm doing. 1, 1. Did y'all get it? How many faculty? 100. That's correct. You could have used substitution, then elimination. You could have used algebra, right? I just thought, you know what? I can have 3 equations. Okay. Number 16.
How did you get 100?
Okay.
I did not get
What did you get?
100. Oh, your matrices have to be wrong.
Yeah, I got the same.
Oh, really? Okay, y'all want to look at my matrix? because it was S plus F plus O equals 460. So it's 1, 1, 1. We're just looking at the coefficients.
Are we doing 16?
16, yes. All right, an alloy containing 40% gold, I'm going to call that G40, and an alloy containing 70% gold, G70, are to be mixed to produce 50 pounds, and that's going to be gold 60. So this is how much? This is how much of each. This was exactly like what we did in Algebra 2. Then we have the weighted. 40% times gold 40 plus 70% times gold 70 is 60%. I know how much gold 60 I want. Is 0.6 times 50, is that just 3?
It's 30.
It's 30. Okay, I think I'm just gonna do matrix. I mean, why not,
Would
right?
it be a 2 by 3?
It's a 2 by 3, yes. Okay, that was so easy. How much gold 40?
I got 16.6.
I have mine in mine is fractions. 16.6. Yeah, I got 50 over 3 because mine's in fraction. I bet that's the same. What's the gold 70?
33.3.
Yes, that's 100 over 3.
Are there gonna be any word problems like this?